Okay, so basically it's similar to a network of activities that we draw on layout tutorial session 2 weeks ago. We put each activity based on the predecessor info we have on the table. And remember, in the project management, if we want to make the network design to determine the project schedule, we have to use this activity format for each activity. In this circle, we have the name of the activity time, earliest start, earliest finish, latest start, and latest finish. For each element will be explained later. Okay. First, here we have activity A. It doesn't have predecessor activity, so we just put it here. Don't forget to use the circle format. And then activity B, it doesn't have predecessor activity as well, so we cannot put it right after the activity A. They're not connected, so we put it separately. And then activity C, its predecessor is activity A, so they're connected, and we put it after activity A and connect them. And then activity D, its predecessor is activity B, so D and B are connected, and we put D after activity B. Okay. Activity E, its predecessor is C, so we put it after C. And then activity F, its predecessor is D, so we put it after D. Next, activity G, it has two predecessors, E and F, so we put it here after E and F and connect it to E and F. And then next, activity H, its predecessor is only G, so we put it after G and connect it to G. Then we have activity I, its predecessor is activity H, so we put it after H and connect them. And then J, its predecessor is on activity H2, so we put it after H and connect them. So we could see here that activity H have two branches. Last one is activity K. It has two predecessors, I and J, so we put it after I and J and connect it to I and J. Okay, now we already have the network design. We put the number of days each activity needs to be done. Just put the number on normal time column, just shown in the table, okay, in your paper. But after that, we still have empty boxes on earliest start, earliest finish, latest finish, and latest start section, okay. So now we just have to fill the activity time first for all activity. Okay, now we are done placing activity time on each activity, but now we still have empty boxes on earliest start, earliest finish, latest finish, and latest start. Okay, maybe we could begin from earliest start. So basically, earliest start is earliest time at which an activity can start, assuming all predecessors have been completed. We get it from the maximum earliest finish of all immediate predecessors. But since activity A doesn't have any predecessors, the earliest start is 0. To make it easier, I'll give the sign on each box side. Next, earliest finish. We get it from adding the earliest start with the activity time. So for activity A, the earliest finish is 12. Anyway, for earliest start and earliest finish, we do it by forward pass. It means we do it from the start to the end of activity, while LS and LF, we do it by backward pass. It means we do it from the end to the start. So now we fill the ES and EF boxes first. And since activity B doesn't have any predecessor, so it's just the same with activity A. Okay, Continue to activity C. The earliest start is 12 days because its predecessor is only A, and the earliest finish of activity A is 12 days. For the earliest finish, we get it from earliest start, which is 12, plus the activity time, which is 7 days. So the EF for C is at day 19. And then we do it the same for the rest of activity. But here at activity G, it has two predecessors, E and F, and to determine the earliest start for G, we choose the maximum earliest finish between its predecessors, which is E and F. So earliest finish of activity E is at day 29, while earliest finish of activity F is at day 14. And between 29 and 14, the longest time is 29. So we put 29 here for the earliest start of activity G. For activity I and J, they have the same earliest start because it has the same predecessor, which is activity H. For activity K, the case is just the same with activity G, so we choose the longest time for its earliest start. Now we are done filling the earliest finish and earliest start forward pass. Next, we're filling up the latest start and latest finish, and we do it backward pass from activity K to activity A, and we're starting from activity K. Okay, since it is the final activity, so its latest finish equals to its earliest finish. So its latest finish is also 57. Okay, and then for the latest start, we have to reduce the latest finish with the activity time. Next, activity I and J have the same successor, which is activity K, so they have the same number for their latest finish, which is 54, the latest start of activity K. And for the latest start of activity I and J, just reduce each latest finish with each activity time. For activity H, latest finish, we get it by choosing the minimum latest start of its successor activity, which is I and J. I has 46 and J has 51, so we choose 46 instead to fill this box. For its latest start, just reduce the latest finish with its activity time. Okay, next activity G, its latest finish is 32, which is the latest start of activity H. For activity E and F, their latest finish is equal to latest start of activity G. This is the same case with activity I and J before. Okay, then just repeat the steps for the remaining activities backward, and we're done with question A. Before we determine the critical path, we have to know the slack time first for each activity. So basically, slack time is the length of time an activity can be delayed without delaying the entire project. We can get it from the latest start minus earliest start, or latest finish minus earliest finish. So it's like start with start or finish with finish. For example, slack time for activity A, we could get it from 0 minus 0 or 12 minus 12. Okay, So its slack time equals to 0 days. Next, activity C, its slack time is 12 minus 12 or 19 minus 19. It's all up to you. And then for E, 19 minus 19 or 29 minus 29. Okay, then you can just continue calculating the slack time for the other activities using the same formula. After we got the slack time for each activity, now we could define the critical path. We choose any activities which have 0 days for its slack time. So based on that, we choose A because it has 0 days, and then C, right? And then E, G, H, I, and K. Now we have to compute the total activity time for the critical path. Remember, for the activity time, we look at these numbers, okay? At the bottom of the name of the activity. Just sum all of them. But only for the activities that's on the critical path. So, based on the critical path, in normal time, this project takes 57 days to complete. Now, problem 1.C. Before we find the additional cost, we have to find the crash cost per time for each activity on the critical path. And we get it by using this formula. For crash cost, normal time, and crash time, you can find the number on the table given. For example, activity A, its crash cost 18 minus its normal cost 12 million, and then divided by its normal time 12 minus its crash time 8 days, and crash cost per time equals to 1.5 million. And then just continue calculating for the other activities on critical path. And there are C, E, G, H, I, and K. After we got the crash cost per time for each activity, then we choose activity which have the lowest cost, which is A with 1.5 million. But look, activity A only have 4 days to crash. We got it from 12 days minus 8 days or normal time minus crash time. Well, we want to complete the project 7 days sooner, and it means we have to find another activity which have the second lowest cost to fill the last 3 days. From the calculation, we find that activity H has the second lowest cost with 1.6 million, so we choose it to crash the last 3 days. Actually, activity H has 5 days to crash. We got it from 14 days minus 9 days. Well, we only need 3 days more to make it 7 days sooner, right? So the calculation for the additional cost goes like this. 4 multiplied by A, it means 4 days multiplied by the crash cost of activity A, and then plus 3 days multiplied by the crash cost for activity H. After we calculate it, we got 10.8 millions. So the additional cost for crashing 7 days sooner is 10.8 millions.